The uncertainty principle talks about two operators that are both Hermitian and states the following. So given is a theorem or uncertainty principle given two Hermitian operators A and B and a state psi normalized, then the following inequality holds. And we're going to write it in one way, then in another way. Delta A psi squared times delta B. Sometimes people, in order to avoid cluttering, don't put the psi. I don't know whether to put it or not. It does look a little more messy with the psi there, but it's something you have to keep in mind. Each time you have a uncertainty, you are talking about some specific state that should not be forgotten. So maybe I'll erase it to make it look a little nicer. Delta B squared. Now, it's an inequality, so not just equality, but inequality. That product of uncertainties must exceed a number, a computable number, which is given by the following thing. Okay, so here it is. This is a number, is the expectation value of this strange operator in the state psi squared. So, you know, even such a statement is somewhat confusing because you wish to know what kind of number is this. Could this be a complex number? If it were a complex number, why am I squaring? That doesn't make any sense. Inequalities, these are real numbers. Deltas are defined to be real numbers. They are the norms. So this is real, positive. This would make no sense if this would be a complex number. So this number better be real. And the way it's written, it seems particularly confusing because there seems to be an I here. So at first sight, you might say, well, can it be real? But the thing that you should really focus here is this whole thing. This is some operator. And against all first impressions, this operator formed by taking the commutator of A and B, this is the commutator, AB minus BA, is Hermitian. Because, in fact, if you have two operators and you take their commutator, if the two of them are Hermitian, the answer is not Hermitian. And that you know already, X with P is equal to IH bar. These are Hermitian operators, and suddenly the commutator is not a Hermitian operator. You have the unit here. A Hermitian operator with a number here would have to be a real thing, so there's an extra I, and that's your first hint that this I is important. So the fact is that this operator, as defined here, is Hermitian, because if you take 1 over I, AB, and we're going to try to take its Hermitian conjugate, we have 1 over I, AB minus BA, and we're taking the Hermitian conjugate. Now the I is going to produce, is going to get complex conjugated, so you're going to get 1 over minus I. The Hermitian conjugate of a product is the Hermitian conjugates in opposite order. So it would be B dagger, A dagger, minus A dagger, B dagger. And of course, these operators are Hermitian, so 1 over minus I is minus 1 over I. And here I get BA minus AB. So with the minus sign, this is 1 over I, AB again. So the operator is equal to its dagger, its adjoint, and therefore this operator is Hermitian. And as we proved, the expectation value of any Hermitian operator is real. And we're in good shape. We have a real number. It could be negative. And the number, when you square it, is going to be a positive number. So this makes sense. We're writing something that at least makes sense. Another way, of course, to write this equation, if you prefer, this inequality, I mean, is to take the square root. So you could write it delta A times delta B. Since this is a real number, I can take the square root and write just this as absolute value of psi 1 over 2I AB psi. And these bars here are absolute value. They're not norm of a vector. They are not norm of a complex number. They're just absolute value because the thing inside is a real thing. So if you prefer whatever you like better, you've got here the statement of the uncertainty principle. So the good thing about this uncertainty principle formulated this way is that it's completely precise because you've defined uncertainties precisely. Many times when you first study the uncertainty principle, you don't define uncertainties precisely, and the uncertainty principle is something that goes with sim. This approximately equal to this, and you make statements that are intuitively interesting but are not thoroughly precise. Yes, questions? Yeah.
Should that be greater than or equal to?
Greater than or equal to, yes. No miracles here.